Today's math strategy video is on connecting area and perimeter. So in earlier lessons, we talked about how to find the area of composite shapes by decomposing them and then adding the areas together. So in today's lesson, we're going to connect what you already know about area to perimeter. So our example problem here says the L-shaped figure below shows the shape of the rabbit pen. The side lengths you know are labeled. Okay. So for this shape here, it already gives us in the blue, it already gives us the meters of some of the sides, but we do have an unknown side. So we did talk about in the previous lessons, whenever we were finding area and we had to find a side that we didn't know, we talked about parallel lines. And this is really important because when I can find a line that is parallel to the one I'm trying to find, that can help me solve for the unknown length. So when you come across a problem like this, you got to make sure that we think about what measurements do we already have. And if it's a vertical measurement, I'm going to look for other vertical measurements. If it's horizontal, I'm going to look for those other horizontal measurements, those parallel lines. So here I'm trying to find this length right here, this unknown length. This is a vertical line. So I'm going to find another line that runs parallel to it. So parallel would be another vertical line. So over here, I have the other side of this composite shape. So this line's right here says that it's 3 meters long, okay? So that doesn't mean that this equals 3 meters because you can see right here that this is short. So I really like to outline these because that helps me see. This one's longer, so I can't just say, well, this is 3 meters because that's 3 meters, okay? I'd have a missing little piece right here. But I see here that it tells me what this would equal. So this little piece right here, so if I took this apart and I brought this down here and I just looked, I did this, took this little shape out, but I know that this little section right here is 1 meter and that this one is 3 meters. So that means I just need to find this part here. So if this is 1 meter, I know that if I add 1 meter plus something, it's going to give me 3. So 1 plus something it's going to give me 3 meters. So this has to be 2. This unknown length has to be 2 meters long. So that is the strategy that I use in order to find a missing side length. I think about what runs parallel. If it's vertical, I find other vertical lines. If it's horizontal, I find other horizontal lines. So now we're not done. So if we want to find perimeter is the measurement of the outside of a figure. So we talked about area is like the inside, like if I shaded this in, this would be the inside, the flat surface inside of the shape. Well, I'm going to find the perimeter, so that would be the outside. So I need to add all these measurements together. So I'm going to start over here. I'm going to put a little check mark next to each one I write. That way I know I wrote all of them down so that I can add them. 3 plus 2 plus 1 plus 1 plus 2 plus 1. So this would be the perimeter of this figure. So 3, 2, that's 5, 6, 7, 8, 9, 10. So 10 meters would equal the perimeter of this shape. Okay, now let's connect what we know about perimeter and area, and let's put them together. Okay, so you're going to come across some problems where it's going to ask you to make those connections between, a perimeter and area of a figure and talk about what's similar and what's different about them. So our example problem says Jenna made the rectangle below. So let's talk about this rectangle right here. I'm going to count the side lengths. So I have 1, 2, 3, 4, 5, 6. I just like to do that because that helps me so that I've counted them. I know. Now, once I do that, I also need to count these sides, and I do need to include this one, even though it was included up here. So that's 1, 2, 3, 4, 5. So this would be a 6 by 5 rectangle. Now, if it was a square, it'd have to either be a 5 by 5 or a 6 by 6. It would all have to be the same measurements. So a 6 by 5 would be 30, and this would be units squared. Units squared. So if it is 6, this side also is 6, this is 5, and then this side would also be 5. So if I add these up, 6 plus 6 plus 5 plus 5, I can also do 2 times 6 plus 2 times 5. Either one of these will give me the same measurement. So this would be 12, 10, so that would be 22. 2 times 6 is 12, 2 times 5 is 10, and 12 plus 10 is 22. So I can do that either way because I have 2 sets of 6 and 2 sets of 5. So my 22 is my perimeter. So these two measurements are different because my perimeter is only measuring the outside of this rectangle, whereas my area is measuring the inside. It's all of these squares together. Now, our next two problems asked us to create another rectangle with the same perimeter but a different area. So I need to keep the perimeter, but I need to find a different area. So I'm going to use a different color for this. Okay. So same perimeter. So I need the sides to, when I add them up, I need it to be 22. And then I need the area to be different though. So when I think about this off to the side, I know that these two measurements are going to have to be the same. This side, A and A, are going to have, these two have to be the same. B and B, they have to be the same. These two the same, and then these two have to be the same. And I need to add them up to 22. So something I can think of just right off, I can do a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can do a 1 by 10 because if this is 1 and this would be 10, so let's make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1. If I add these up, 1 plus 10 is 11, and 1 plus 10 is 11, and 11 plus 11 is 22, but my area would be 10 because it's a 1 by 10. So this would have the same perimeter as that, but obviously it's a different area because this is not as large as that. Another one would be a, let's see, 1, 2, 3. Let's do a 4 by 7. Would this work? 1, 2, 3, 4, 5, 6, 7. Is that 7? 1, 2. So if I have 7, 7, a 4, and a 4. So 4 plus 4 is 8. 7 plus 7 is 14. That would be a perimeter of 22, but this would have an area of 28. So I could have a 1 by 10, or I can have a 4 by 7. That would have the same perimeter, but a different area. Okay, our next problem says create another rectangle with the same area, but a different perimeter. Okay, the area was 30 units squared, but I want a different perimeter. Okay, that means I need to make sure that the length and the width, when I multiply them, that I get 30. So I need to find all numbers that I can multiply together to get 30. So right off the bat, I think of a 3 by 10. 3 by 10 will get me 30. Let's draw that out and see. 1, 2, I got 3. Let me erase that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a 10 by 3, that'd be 10 here and 10 here. So a 10 by 3 would be 30, but the perimeter would be 10 plus 10 plus 3 plus 3, which would be 26. So that would give me a same area but different perimeter. Another one, I'm not going to draw it, but another one could also be a 2 by 15. If I had a 2 by 15, what would be the perimeter? Well, I would have 2 sides. One would be 15, another would be 15, and I'd have 2 and 2. So I would have, this would be 30, it would be 34. So that would give me same area, different perimeter. All right, that is the end of today's math strategy video.